Good morning, and I would like to take your attention to proteomics for a few minutes. I followed the recommended structure of the presentation, and I will start with, I suppose, quite known fact that we are operate in a full service mode in majority. So you just bring samples and it will give you results. So that's the reason we don't do any trainings courses or something like that, but we are still open to provide consultation on the topic. We are also participating in teaching. We can provide students baccalaureate diploma, also PhD studies. So this is in this way, and our structure of services remains almost the same. We can divide it in 4 categories. The first one is intact mass measurements, where we can provide determination of molecular weight of your molecules and also multi-MS profiling of bacteria. Protein identification, which is connected with protein quantification very often, but in this category I would like to mention characterization on protein interactions, not only protein-protein, but also protein RNA or DNA. We are using immunoprecipitation, or we analyze immunoprecipitates, or some proximity labeling assays such as BioID or TurboID. So next we can analyze protein modifications, especially post-translation modifications. Again, mainly phosphorylations, which are on demand most frequently, but also acetylation, methylation, and so on. Then epigenetic marks, and of course, protein quantification is most important. We prefer label-free approach, but we are able to work also with SciLake or TMT tags. And if you are really interested in such kind of proteomic analysis, just contact us. We will discuss. See. Despite the structure of our techniques are similar for years, we want to follow trends, and so that's the reason we implemented ion mobility to our measurements. It brings another separation dimension, so we can distinguish some molecules which are not possible to distinguish on classical mass specs, measuring only M/Z ratio. We have at the moment 2 instruments which can provide ion mobility separation, and both of these instruments also can work in data independent acquisition mode, which can better map complex protein mixtures, so we can go to higher dynamic range and also more identification. You see, we can identify over 7,000 protein groups per injection, and also thanks to new instrumentation which we will obtain next year, we would like to approach single-cell proteomics. Here I just show results from Matthias Mann lab, where they analyzed HeLa cells, and here it's marked 0.8 nanogram of digest material from this cell, which corresponds actually 3 HeLa cells. And we could see, they could see about 500 of proteins. You see that this increasing input amount of digest, we could see more and more identified protein groups. So that's trade-off. So we will see there are also publications at the moment on real single cell analysis. So it's, in my opinion, amazing that we are also at proteome level, we are approaching such a small scale analysis. based on nature of our operation, we try to store all user data for quite a long period, because people comes back to analyze data after several years. So up to now, we are able to do it. We have our data policy at the web page, so you can read it. And of course, we are able on demand provide users with raw data. It's no problem. And also we can arrange a deposition of your data on publicly available repositories, which is standard in when you want to publish proteomic data, you need to make them public. So we can do it also for users too. The question is how long we can do it, because these new instruments also size of data are increasing. So up to now we are safe, but in perspective of several years we will see. I would like to stop this part with my usual request. If you plan some more complex experiment, proteomic experiment, please contact us, and we will discuss not only our experimental design, but also your experimental design, just to put them together with aim to get maximum from this experiment. Sometimes people comes and based on their experimental design, we see that we cannot get optimal results. So please contact us. We will discuss. And another news from our side is that we are preparing a new web page based format of our reports. So it might be more flexible, more informative. So, but of course, it might be obstacle for people. They are used to our Excel format reports, but I believe it's a step forward. So that's all. And coming to a user survey, at first I would like to thank to all of you which spent your time on filling these forms. I am not going to today talk about parameters which was well evaluated, but I would stop about our long-term problems and its promptness of service and results. I would like to stress that it's only for LC-MS experiments. I believe that users would use our MALDI-MS. They are satisfied with response time, and you see if you look according to number of processed samples, most of samples are on MALDI-MS. It's also because MALDI-MS analysis really flows through quick in most of cases, but this LC-MS experiments takes several months, so it's sometimes not acceptable for users, I believe. These reasons are several reasons for it. I have to say, never we will provide these complex experiments, results of these complex experiments, requesting LC-MS analysis in weeks, because if you think, if you have, I don't know, 30 samples for this quantitative study, at least several days takes sample preparation. At least 1 week takes, more than 1 week takes just measurement on instrument. Follow-up database searches might take also several days. And if you think that at the moment we reduced queues on instruments to 2-3 weeks, and even if we allocate instrument time for you in advance, due to some technical issues might be postponed, this experiment. So even this technical part takes several weeks. And then we have to also validate data, process data properly to give you a really high quality result, which is our aim. So anyway, we were trying to do it to reduce this time for LC-MS analysis. So we try to reduce time of chromatographic runs. It's not sacrifice quality of data. Now, for example, we are changing processing pipelines because we are moving from DDA to DIA acquisition modes. So we need to use another software tools for it. And of course, we try to optimize the movement in the lab. So, but anyway, in my realistic estimate, we would like to go for 2 months for such kind of experiments. I am talking about experiments which takes, which deal with tens of samples. So again, a reminder for acknowledgement. We are also a member of a family of CIISB core facilities, and this infrastructure is really critical for us, mainly for investment to new instrumentation. So please, if you publish any data from our lab, as my colleagues, I ask for acknowledgement, and I would like to thank you to all of you. You do it because last year we have 29 papers with acknowledgement to our core facility, and I selected just 4 examples. The first 2 are from 2020 year. It's examples of international cooperation, and second, the last 2 are recent publications coming from internal cooperation in CEITEC. One is from Pavel Plevka group, and second one it's from Štěpánka Vaňačová group. And what I like on it, that all these publications are as a first authors are PhD students. So we mostly work with PhD students actually in our lab. And here I would like to thank to my team. It's joint picture of core facility and research group, associate research group. Without research group, we couldn't actually provide our proteomic services in such extent as we do. And I'd like to thank you for your attention. That's all from my side.
Thank you. So there is space for questions, and so far we don't have question in the chat. So,
I may ask, that the old problem you mentioned, waiting for the data. You mentioned 2 months for advanced analysis. How long it would be for our typical task, which is phosphorylation of a single protein in vitro by a single kinase?
Yeah, it's
still very advanced, or
it's the same chapter as because we need to LC-MS for this analysis, and in case of phosphorylations, there are also a little bit more complicated sample prep because we do enrichment of phosphor usually in most cases. So it takes, but sample prep is not this deciding step in this long processing time. So mainly it's waiting for a slot and then this processing of data. Because, for example, in your case, we do manual interpretation. So this is another category because Katka goes through each spectra, each identified phosphopeptide and check if if localization of site is fine or how to, so this also is slow.
And when you do, you know, complete proteome analysis in terms of phosphorylation analysis, you also do it in this careful manner?
No, you cannot do it because you will get, I don't know, 10 thousands of phosphopeptides. Yeah? So if you do it, whole proteome phospho study. Yeah? So here you have to just believe these statistical tools. There is some FDR, and you have to believe that what they provide. The problem is with localization. So this is what we are quite critical about, because all these software tools, even if people say it works, and so it's not so reliable. So that's it on communication, how to, it's better if you have some candidates, we can check it in this manual way, but not the whole list of.
You talked about, sorry, no? Okay, thank you. So you talk about that sensitivity with those 3 HeLa cells. Have you ever tried something similar with plant cells?
Not with plant cells, because nobody asked us for such small samples. But of course, for example, Helen works with these flowers, and so, and these samples of tissues are really small. So here we are still limited for analysis of such kind small samples. But it was a plan. So now we will build another more sensitive instrument, and what was not possible last year, maybe it will be possible next year, because the dynamics in instrument development in mass spec for proteomics is really high.
I just wanted to follow the general problem of this MSMS analysis. Can help if you, or are you able to train people, for example, that they will evaluate their data by themselves?
Of course, we can train them, but it takes several months actually. Yeah, so that's actually a reason why we don't provide it. We have some Pavel Bouchal, who is involved in topic, and he's expert on data processing. He has softwares on it on by own. So for him we just measure data and he processes the data. But if you come once a year,
No, I don't mean.
No.
But
Just,
but if
just example.
If you have, for example, some users that were coming in a regular period of time, so maybe it can help. And then you will have much more time for our sample.
I am not. I am a little bit skeptic to this.
I don't know.
Yeah, because
this is my question. Maybe it's so difficult that it has no sense. But yeah, I can imagine they have it also on some machines. Yeah, if they run in service mode. But for example, if someone is coming with using AUC from Prague, then they measure by themselves. They evaluate by themselves.
So the problem is that the people which are coming to us are not interested in proteomics at all. They need the results because they are molecular biology. They are involved in molecular biology or something, and they don't want to sacrifice the time for it. So it's my personal opinion. And also, if you do experiments twice a year, for example, because if it's complex one, twice a year is fine, more than enough. So it's difficult to keep this experience. We do it every day. We have pipelines for it. Also, these statistical tools are already automated. So we are not closed to this option, but usually I would prefer it if it's in terms of some long-term cooperation. So when someone is involved in proteomics as a important part of his PhD study, for example, why not? He can come, we can learn him how to measure, how to process. But if you come just occasionally, I suppose it makes no sense.
Perhaps in our case, in the case, single protein phosphorylation, would that improve the flow if we get the data and analyze them by ourselves?
No, of course, it would be faster. It's, in principle, should be faster, because the measurement of data in this case, it's again lower part of, except this waiting for slot or something. But this.
Yeah, we are used to planning the experiments in advance, waiting for the instrument. But then, if after the data arrive, if this period can be shortened, that would really help us. Because,
I understand that.
Ask a question, look at the data, and go for another experiment. If there is a gap of 3 months between this, it makes this longer. So if it helps, if we...
That's the reason what I talked about. The problem is that we now analyzed twice more samples than we did it 2 years ago, but it's still not enough. But now I believe, because we are trying to buy also another type of chromatographs, so some kind of analysis might be really shortened, and thanks to automated processing pipelines, might be shortened also the whole. We will see, So we are working on it, but up to now, all improvements was swallowed by increase of the samples. So that's right.
Yeah, we have the question in the chat again related to COVID research. Were there any use cases?
I have to say we didn't have any consistent study on this topic in the web.
Question about the amount of data that your facility generates. How much are you doing?
Yeah, we are approaching tens of terabytes per year. I would say at the moment, something, just rough estimate, 50 terabytes per year. But it might be up to 100.
In the near future.
Because these timsTOF instruments, they are very fine, but they are producing quite a lot of data. And so